Hello friends, welcome to my channel. Let's have a look at problem 2370, longest ideal subsequence. In this video, we're going to share a solution based on dynamic programming. Meanwhile, we want to make some remark or extension to this problem. So this problem asks us to return the length of the longest ideal string. So the problem defines the ideal substring or is like the following. So first, T is a subsequence of the string S, and secondly, the absolute difference in the alphabet order of every two adjacent letters in T is less than or equal to the given threshold K. So another thing to notice is that here we are considering subsequence, not subarray, a substring. So here are two examples. So in example 1, so the output is 4, and so here ACBD is such a sequence with length 4, and in example 2, so the return is 4, so the S itself is such a string. So here the constraints are as follows. First, the length of S is bounded above by 10 to the power 5. In other words, the length can be up to this number. So this is a large number. So we cannot just use pure brute force. For example, square term complexity solution might not pass the test cases. So K is bounded above by 25. So this actually, if we look at it together with the third constraint, so this is a consistency assumption because we only have 26 lowercase English letters. So with that said, let's look at the method here we're going to share. So the method is dynamic programming. So here, before we do the code, actually we can do a digest. So this is not necessary, but good to understand. So because of the requirements in the problem, we can think of the correspondence. We can think the lowercase English letter to an integer. So for example, we can map to the cardinality, ordinality, or we can just use A to be mapped to 1, B mapped to A mapped to 0, B mapped to 1, Z mapped to 25, or any start and then any incremental ends. So this way, actually, we can think of this S as corresponds to a integer array, right? So the second item in the definition of ideal is nothing but the two numbers has absolute difference bounded by the given number K. So here the two numbers means the two adjacent numbers. So with that said, I guess, so we are ready to explain the DP table and DP update rule. So here we are going to define DP table, so which has a length 26 because we have 26 lowercase English letters. So DPI will be the length of the longest ideal string ending at the character corresponding to index I. So if, for example, we use the above correspondence. So you can think of I as a character if we do not want to use this correspondence. So again, so DP has length 26 because we have 26 lowercase English letters, or we can think of these numbers like 0 to 25 as above. Then the DP update rule is actually very straightforward, right? So this is the maximal of DP running from I minus K and to I minus 1 to DPI, then to DPI plus 1 up to DPI plus K. So then plus 1. The reason is that so the previous character to connect with I shall have index in the range I minus K, and the upper one is I plus K. So this way, the I and the index will have a absolute difference bounded by K. So finally, we just need to return the maximum of the DP table because the longest substring should end at a certain character. So that's the DP update rule. So then actually writing a solution to this problem is rather straightforward. But before we do that, we want to make some extensions so that may be more beneficial than solving this problem itself. First, what if we require the absolute difference of the two adjacent letters equals k? So actually this will correspond to a easier condition. Or if we want the absolute difference of two adjacent letters to be equals positive k. In other words, we want it to be increasing and the latter letter has a ordinality gap with the previous one by k, right? This actually corresponding to an arithmetic progression. So secondly, what if we drop the requirement of absolute difference, but we require the subsequence be non-decreasing or strictly increasing? So for example, this corresponds to find the length of the longest increasing subsequence of the corresponding integer array. So, and the third one is that what if we require a substring with the above variance? So because in the problem we are considering subsequence. So what if we consider subarray or corresponding substring? So that's the three questions and we can ask. So now let's look at the code. The code actually is rather straightforward, I would say. And first, so here, if we want to get this correspondence, you do not need to type brute forcefully. So we can actually do this. So from string, so we can import ASCII lowercase, and then you can print it out. For example, D is the character and the ordinality of character minus ordinality of A for character in ASCII lowercase, right? So we can print out this D. So this is actually what I do for getting this correspondence. So, but you know, this is not strictly important, but let me comment this out. So also comment this out. So with that said, now let's look at the code for this specific problem. So first, let me initialize a DP table. So initially, we use 0 times 26. The 0 means that some letters might not appear in the string S given, right? So if a letter appears, so the length of an ideal string is at least 1, right? Then with that said, we are ready to do the update. Then we can check for character in S. So what we want to do is first we want to get the index I. So corresponding to this kind of thing, 0, 1, 2. So this is computed by computing the ordinality of this character minus the ordinality of character A. In other words, we compute a relative index. So that's sufficient for this problem. And then we do the DP update. So DP update. So it's actually the maximum of the DP table. So then we need to consider I minus k, then any at I plus k, right? So we want to plus 1 here. And then we need to consider the case. So if I minus k might be less than 0, so we want to use max of this I minus k and 0. So this is very safe. And here I plus 1 plus k can be above 26. So we want to use min of this, then up to 26. So this way actually finish, sorry, we need to add 1. So this means we can append the previous character with the character corresponding to this index I. So that's actually that finishes the DP update. Then what we need to do is just return the maximum of DP. So if we introduce extra variable, for example result, then we just need to update the result state in between. So let's write in the current way. The reason is that this is more straightforward. So with that said, let's do a special case check. Yeah, it passes the first example. Now let's do a generic case check. Yeah, it passes all the test cases. I guess with this problem, that's about it. Thank you very much.